everyone. It's great to see some familiar names up on the list of participants. I'm very excited to do this second webinar with you guys, going over our fusion workflow for OptiSplint and just going over how OptiSplint is being used today in a lot of offices for final prosthetics. So let's start with records. The records required for digital full arch, and really it's the concept is these are the records that you really need to digitally design a full arch prosthesis. These records are facial photos or a facial scan, and we'll talk about a little bit about what kinds of photos are ideal, what would you need, things like that, or at least just the baseline of what they are. I'm using my dad here as my example for the facial photos because I want to protect the identities of the patients, but it's just a nice time to be able to recognize my dad. We also want to make sure we capture an ideal final bite, which means the bite that you want to submit as a record to your lab for them to digitally design a prosthesis is one that you want is the bite that you want the patient to end up in their new prosthesis, not their current bite. So if their current bite is collapsed or if there's any other issues with their bites, then those things need to be mostly corrected if you can in this before you capture this record, so that you can make sure that your designer knows exactly how they're going to design that prosthesis. We also want to make sure we capture the vertical position of the tissue relative to the dental implants. So wherever the implants are placed, we want to make sure we know how high the vertical position of the tissue is, where it is in relationship to those implants. And also, of course, very importantly, we have to capture highly accurate relative dental implant positions. There's plenty of ways that you can do this. Of course, we love to do it with OptiSplint, where we're capturing both a digital and analog record that's highly accurate of the dental implant positions. But just to simplify this, and to add one more kind of cog into this system, is I want to categorize each one of these records as the face record, bite record, the tissue record, the implants record, and then we're also going to be capturing some alignment records. I've also color coded it for you guys to keep it simple so you guys can follow along really easily. So the purpose of these records ultimately is to align the three-dimensional models of the face and bite and the tissue and the implants in the same three-dimensional coordinate system. So if you look at this, I guess, image from exocad, you could see how we have the upper antagonist, we have the lower prosthesis, the wax up, all aligned in the same XYZ coordinate system in three-dimensionally, right? And if you look through, it's a little bit transparent. You can actually see the OptiSplint and behind the teeth there. And you can see everything is aligned, everything is all together in that same coordinate system. And that's going to give you the ability give a well-trained technician the ability to design a very nice prosthesis for this patient and then manufacture that prosthesis for that patient and do it very efficiently and do it well. And basically, these records are, you want them to be as accurately overlapping each other as possible, as true to the patient's jaw as possible, because ultimately, the better job we do with this, and the more accurately we're able to align all those pieces, the less adjustments there will need to be made when the prosthesis is actually placed in the patient's jaw. So in terms of the digital tools that are required, I highly recommend a mirrorless camera with a macro lens. If you don't have that, you definitely want to have some kind of a facial scanner. The two that are on the market right now that are getting the most attention are the RayFace by Ray and the MetaSmile by Shining 3D. They're both really good scanners, and they both work really, really well. The other thing that you would definitely need is an intraoral scanner. We always recommend the 3-Shape Trios, especially the Trios 5 or the Trios 4 that's on the market right now. And then the Dentsply Prime Scan, the Medit 700 is also a great one. We've seen iTero work. There are some challenges sometimes because their AI is a little different. The Shining Oral Scan is also a great option as well. It's on the market. So let's start with the facial photos, the face records, right? Um, so I worked for InSequence for quite a bit of time. So we used to always go over these records over and over again. Basically, like what kind of digital records do we need? And what kind of face photos do we need? And we always ask for a minimum of these 4 photos. The first one is just a repose. Basically, they're just resting and their lips are a little bit open. You could see the teeth through the lips. And we basically just have the patient say duh, and they will give us kind of that look to it, right? We also want to make sure they give us a natural smile where, they're just smiling like happily as much as they can. And then we ask for a big smile, right? Where maybe you're telling a dirty joke to somebody or something that it's really going to make them, smile really, really big. And of course, very importantly, we want to capture a retracted smile because it's ultimately that retracted smile that will usually give us the ability to uh, align the data of the teeth to the digital record of the three-dimensional record of the scanned teeth from the intraoral scanner. That's going to make it easier for us to align all the data together because you could use the face or features on the face to align the other parts of these photos into your exocad record to start doing the design. But as you could see, my dad, obviously, you could see a lot of his teeth in his big smile, so you may not have needed the retracted smile. But there are some patients out there that just don't smile very big, and their lips are often together. So having that retracted smile will give you the ability to do better alignments with these photos. Now, of course, your other option for the face is a facial scan. You can see the Medit on the right, the Meta Smile, and the Ray Face on the left. They're both great options. They're both good ways to capture this face photo. Now, if this face photo looks anything like my dad's photo, it's actually not my dad, it's actually me. So I took this scan actually not with one of these scanners. I recently acquired a little toy that I have that I'm playing with to capture three-dimensional images. And I was able to capture this scan of my face recently with that scanner. When it comes to the digital bite record, again, I said you really want to try to capture the ideal bite, which means ideal occlusion. Now, I've gotten a myriad of lectures from my co-founder, Dr. Crockett, on what all of these things mean, and I still am not certain I can tell you exactly what all of these terms mean. So unfortunately, I'm not a clinician, but there's all these things that are worth understanding and as a clinician to make sure that you're capturing ideal occlusion of the patient prior to submitting this record, and understanding how to capture that ideal occlusion, what it takes, what it is, and all those things. But you'll see a lot of these terms when you start to really understand occlusion a lot more. I just don't have the brain, I think, to keep this in my head of what all those things are. But it is something that's worth learning in occlusion class. The other part of it is the vertical dimension of occlusion. It's basically just the idea of capturing where that bite is in relationship to the face. That's why you want to have facial photos or a facial scan, so that you can actually ensure that the vertical dimension of your occlusion makes sense in that patient, so that where the teeth come together when the patient is smiling, all that stuff it looks natural and it looks right when you actually give them that replacement prosthesis. Now, I do want to highlight a bonus resource for you. If you scan this code, you'll go to a website at the Mod Institute where you'll be able to actually download a printable VDO gauge for free. The Mod Institute is a educational institute that I have a lot of respect for. This gauge was designed by Dr. Wally Renee and Dr. Baron Gruder. They are extremely, extremely well educated and intelligent and incredible clinicians that have done a lot to make this procedure a lot easier and a lot faster. And this is one of their contributions. This is VGO gauge. So I would encourage all of you to scan this code on their website, sign up for their newsletters and their websites and learn about their education there. But you'll also be able to download this STL file. And it does work really well. I printed it myself. especially if you print it in like a Flexera material, a stronger material, it actually does work extremely well. You can kind of capture and hold the patient's VDO really, really nicely with this VDO gauge. The next thing that you want to capture, obviously, is the vertical position of the tissue. The purpose of this scan is really to capture the vertical position of the tissue between and adjacent to the three-dimensional dental implant positions. So wherever those implants are being placed, you want to make sure you're able to capture how much tissue is rising above or rising next to the multi-unit positions or the implants, so that you can, when you're designing the prosthesis, you can design a nice uh, convex, ideally, but or flat surface, so that it could be a very ideal and clean surface for that patient. So it won't trap food and other particles in there. You just want to try to make sure you capture that tissue in terms of the position of it, the height of it, in between each one of the implants. The reason why I don't say you need to capture the full contour of the tissue is because that usually often traps the designer into, I mean, you capture that anyway, but if the designer's thinking in those terms, they'll often just create an intaglio surface that's almost contoured to the tissue. And you don't necessarily want that, because when you contour a tissue, it's very bumpy, it's going up and down. That's going to create pockets of uh, food particles and other things for bugs to grow in there. You just don't want that in a prosthesis. You want to really just try to keep the bottom of your prosthesis as flat or as convex as possible, so that it is as hygienic as possible. And of course, you want to capture highly accurate relative dental implant positions. OptiSplint is one of the ways that this is being done. The other one is photogrammetry. Of course, the iCam 4D is the one that we certainly have done a lot of validation with, and feel that they're probably the most accurate piece of photogrammetry technology on the market today. And but in terms of being able to capture dental implant positions, these two devices really are the only two that are doing it without any sort of human factor, right? So one of the issues that a lot of these other intraoral scanning devices have is they're leaving a lot of human factors on the table. If you're using an intraoral scanner and you're scanning uh, some kind of device intraorally where all of the pieces are kind of touching each other or they're close to each other, you're still scanning in an environment where there's blood, tissue, saliva. The patient might be moving. So the patient is absolutely one major human factor. The second human factor is how well trained the person that's scanning the device is. Like if you actually go to the Mod Institute, they have a whole day of training, of live training, or that you can take um, in terms of how to capture scans much more accurately. And understanding how to do those scans very, very accurately is a unique skill that not everybody has. So so that second person scanning is also a human factor. So OptiSplint technically isn't an intraoral scanning device. We don't necessarily recommend scanning OptiSplint in the mouth, nor do we necessarily recommend scanning, nor do we actually say that scanning OptiSplint with an intraoral scanner is going to be the most accurate way to capture the dental implant positions with OptiSplint. We recommend scanning OptiSplint outside the mouth, first of all, and ideally in a desktop lab scanner where you could scan it with a 10 micron lab scanner. That's going to give you the most accurate scan without any human factors. The clinician just needs to know how to do a good job of luting this device together in the mouth and making sure that everything is nice and strong, luted together. Photogrammetry also removes those human factors by basically just capturing dental implant positions with a mathematical equation. They're using geometric concepts that triangulate the positions of dots on the scan bodies and the four cameras and all those things to capture specific distances between each of the implant systems or the implant positions. And so that also does remove the human factor. So it's important to understand these technologies for what they are. These two technologies are really the only two when it comes to highly accurate dental implant positions where they are actually removing those human factors out of it. Most other uh, ways of doing this, including Nexus iOS, still has some human factor. There is still somebody scanning with an intraoral scanner. In Cerisa, some of these other ones that are just pure in uh, I guess intraoral scanning solutions, they are um, uh, they're still leaving some human factors on the table. They're mitigating them. There's different ways that each one of these new ways are mitigating them and trying to make them a little bit less, but they're still going to be there and there's still cause for error. So just a quick summary of these records, and I'm going to go back to these over and over again because I really want to hammer into to those of you that are out there and watching this webinar. I really want you guys to remember these four records: the face, the bite, the tissue, and the implants, because these are the most critical records that you need to capture. And when you start to understand these digital workflows and how everything is aligned, what you'll start to think about is how do I get all of these different records into the same three-dimensional coordinates. So let's go into the Fusion workflow for final prosthetics. So of course, we're going to start with the photos of the patient, right? We want to make sure we use a nice camera with a macro lens, and we want to be sure we're capturing in a good light, a certain distance away from uh, the camera, and we want to make sure we're capturing as straight of a photo as we can when we capture these photos. We want to make sure the patient is looking straight at us, their eyes are open, um, you know, their chin is up, everything is easy for us to align, and we want to capture these photos um, as ideally on a tripod if we can, but if not, we want to capture them from the same position, from the same distance, so they're very similar to each other, so that we could overlap these photos very easily. But again, these four photos that we always recommend are repose, normal smile, big smile, and retracted smile. If you capture these four photos, most lab technicians will be able to do a reasonably good design with these four photos. And but certainly, having a few more photos, a little bit more close up and things like that never hurts as well. A facial scan is always a great option as well, making sure you're capturing the face, in a in 3 dimensions. That way, alignments back to the mouth with the teeth and everything like that are actually going to be a whole lot easier because now everything is 3 dimensional, including the face, including the face records. Capturing the bite with an intraoral scanner, we want to do this intraorally. So you're going to capture the first the lower usually is in at least the 3-shape trios workflow, and then you're going to capture the upper, and then you're just going to make sure that you capture the bite. So we always recommend when you're capturing the bite, most scanners will have you do it twice, one on each side. An important part of that is that you don't let the patient relax or open their mouth or open their jaw at all between the two scans of the two sides. If they do, they're going to be different a little bit. So it's very, very important to make sure that the patient keeps biting down the entire time when you capture the right and the left side of the bite. If they do open their mouths between those scans, you want to start over again. The other thing is we do recommend also having the patient stick their tip of their tongue all the way to the back of their throat if they can before they bite down, so they pull their jaw back into the most ideal possible occlusion that they can get into. If the patient has no teeth or are fully edentulous, we do recommend using dentures and capturing this bite with dentures. But you want to do the upper and lower scan and then that bite scan really as accurately as possible. Now, in this case, we're doing the final prosthetics workflow. So we're actually going to be capturing as part of that bite, the lower prosthesis, right? So this patient is getting their lower prosthesis going from a temporary to a final. And so once we've captured the bite, we're actually going to remove the temporary prosthesis, and then we're going to insert the analog scan caps that are found in the OPTISPLINT kit. Now, these scan caps are friction fit, and they're really nice because they're very easy to get into your prosthesis. It takes just a matter of seconds to push them all in, and then it's very easy to scan without worrying about these things falling out. You don't have to screw them in. You have to use a tool to get them in. They just press fit right in there. And then what you're going to do is you want to push them all in and ensure that all the analog scan caps are fully seated. And then once they are, you're going to scan the prosthesis with these analog scan caps in 360 degrees. So you want to make sure you capture all of them along with the teeth. And what you're going to be using this for is to be able to align the bite to the implants. And I'll show you how you do that when you actually look at the OptiSplint. But in this case, these analog scan caps are being used to help with alignments. So this scan is actually an alignment scan. It's basically you're capturing just the lower prosthesis with these analog scan caps. So ultimately, you're going to actually be aligning this into the bite scan. The next thing you're going to do is you're going to capture the OptiSplint scan bodies and lute it together, or capture the dental implant positions with the OptiSplint scan bodies by luting them together with the frame intraorally, and then ideally using our OptiWeld dual pure composite resin to lute them together. OptiWeld is something that we curated specifically for the purposes of creating a jig. We love it because it is a dual cure material. It is very, very low shrinkage at about 3%, 3 or 4%. And it's very strong. Once it's luted together, it's very hard to break. It's not fragile or brittle or anything like that. It cures very, very hard. It cures very, very strong. And it'll self-cure. So even if you don't get all light everywhere, it's still going to cure very, very nicely. It's also not very runny, so it doesn't drip everywhere when you're putting it in. It's not going to get everywhere. The one downside to it is that it is a little bit hard to get it if you're using just the tube itself to push the OptiWeld out of the tube. That's why we've also released a mixing gun that makes it a whole lot easier to work with this material. But we do recommend using this material when you lute in OptiSplint together. And you get 8 grams with each tube, so that it usually lasts at least a couple of jigs. Once that jig is luted together in the mouth, you can optionally scan the OptiSplint jig intraorally. Now, again, you'll notice that I labeled this scan as an alignment scan, not necessarily an implant record scan. This scan could give you enough tissue to just align the tissue to the implant scan that's going to be done outside the mouth. So you could see around the OptiSplint scan bodies in this scan, you could actually see quite a bit of the tissue in the patient's mouth. You could actually see, most of the tissue that's in between each one of the implants. So you can capture that vertical position of that tissue. Do you really need the tissue that's underneath the frame? Possibly if there's something that's specific you want to do with that prosthesis. And a lower, probably not, but having it here like this would probably give you plenty of data in order to pull that tissue in. And that way you can actually scan the tissue just by itself and even separately and actually pull the tissue in if you want to. But this is an alignment scan. This is not a scan that we would recommend using to indicate dental implant positions in your design. Once we've removed the OptiSplint jig from the patient's mouth, we're going to be doing another alignment scan. So we're going to be inserting the analog scan caps into the jig. And then we're going to be scanning the OptiSplint outside the mouth. So this is actually one of the ways where you can align the data between the dental implant positions and the bites, because these analog scan caps, we give you 2 packs in every single kit. One pack can be used on the uh, one pack can be used on the prosthesis, and the second pack can be used on the OptiSplint. In our library in exocad, we also offer the geometry of these scan caps as the analogs in our library, so that even if you don't capture even if you don't use these analog scan caps in this OptiSplint jig, you can still pull it in from the library digitally to align the data all together, the implant positions to the bite. But you could see that these are the same geometries, the same scan caps that we put in the prosthesis earlier. So you could start to kind of picture in your mind how those two pieces, the bites and the implant positions, are going to be aligned together. Now, we do actually recommend, even if you're shipping this to a lab and you don't have a digital scanner or a desktop scanner in your office, we do recommend that you scan the OptiSplint outside the mouth once it's dried and cleaned of all blood and saliva and all that stuff. And we recommend that you scan it before you ship it to your lab, just in case anything goes wrong during the shipping process, whether it's lost or damaged or broken during the shipping process. The designer from your intraoral scan record done outside the mouth um, will still be a record that they can use to at least design a temporary. And so having this scan is just kind of a precautionary measure. Now, in order to capture the actual dental implant record officially, we would highly recommend scanning it with a desktop scanner, either in the lab or if the clinician happens to have a desktop scanner, and scanning it also with these scan caps in that desktop scanner. You could stand it up and put it kind of in a way that would allow your scanner to capture both the top and the bottom at the same time, or you can just capture them separately and then align them together in your software. But either way, capturing them with the scan caps will make it a little bit easier to align if you don't want to use the digital library to align it. But ultimately, being able to capture this with a desktop scanner is ideal. Or actually, this one I was talking about the intraoral scanner. But the other optional activity that you can do with OptiSplint is you could pour a verified stone cast from the OptiSplint jig. This is not required. You can do a fully modelless digital workflow if you want to. But OptiSplint is unique from photogrammetry in that it does give you the option to pour a verified stone cast. We think this is still very, very valuable because having a stone cast will give you the ability as a manufacturer or a clinician to ensure that any error that is created from the manufacturing process of the prosthesis does not affect the accuracy of the prosthesis prior to putting it back into the patient's mouth. Having a verified stone cast from the OptiSplint jig, which is a different record from the digital record of the scan of the OptiSplint jig, once this is actually poured into stone, you can use it to cement tie bases into a temporary or final prosthesis. You can use it to cure your print. Let's say you printed a temporary or prosthesis or a try-in, and you printed it directly to the MUA without the use of tie bases. You could actually, coming straight out the print after you've cleaned it, screw it onto this verified stone cast and cure it in your curing oven. On the stone cast, you make sure that prosthesis is cured to a perfect record of that of the patient's mouth. And so having this cast really does add that extra layer of accuracy above and beyond the initial record that you're taking of the implant positions. Like that may be very, very accurate, whether you're doing it photogrammetry or using OptiSplint. You may be capturing the most perfect record from that patient in that moment. but you can't necessarily account for from that record. And frankly, it's that record is not responsible for any of the manufacturing error that you might get. And 3D printing is still not necessarily the most accurate way of creating. Um, and a lot of these digital workflows use this, but not the most accurate way at this time to create a final prosthesis. Even with zirconia, when you're doing a full mouth zirconia, the sintering process is a very inexact science. So being able to reconfirm and reorient basically any of that manufacturing into an accurate record again using a stone cast is a huge advantage in my opinion, and it gives the doctors, the labs, and everybody a common language to look at to make sure and to easily understand and be able to figure out where things might have gone wrong in the process if something is not fitting. It is optional, but we highly recommend doing it anyway. Um, the next scan is placing the healing caps or multi-unit scan caps and scanning the tissue intraorally. So you'll notice that there's two different kinds of scan caps in this record. One is the tissue scan of the healing caps, and in this case, I believe it was an MIS case, and those are MIS healing caps. We do have these in our library, so you can convert them into implant positions, basically, or OPTISPLINT records, and that would give you the ability to align this tissue to the OPTISPLINT jig of the implant positions. However, we also started including these multi-unit scan caps in our kit. These multi-unit scan caps are actually the same shape as the back of our scan bodies, the OptiSplint scan bodies. So it makes it so it's very easy to align tissue scanned in this way to the OptiSplint implant positions. But this scan here is a scan of the tissue scan, and basically capturing that tissue position in relationship to the implants. And this is what I was talking about with the desktop lab scanner, making sure you scan this jig or this OptiSplint record, the implant records, with the most accurate piece of equipment that you have. The 3Shape scanner here that I have here, I believe it has 4 microns of accuracy. There aren't a lot of devices out there that are nearly as accurate as this device in terms of scanning. When we were doing some testing of some earlier models of OptiSplint, and we did 10, I believe, identical scans over and over again of the same record, I believe we were getting within 1 micron almost of all of those scans being within 1 micron of each other. So they really are, these scanners, especially this 3Shape V4 is an incredibly accurate scanner. So just to review again, we've captured these key pieces of data throughout this process. We've captured the face, whether it's through photos, high quality photos, or a facial scan. We've captured the bite with an intraoral scanner. We captured the tissue with an intraoral scanner using our scan caps or the healing caps. And we've also captured the implant positions with OptiSplint and scanning it with a 3Shape scanner, a desktop lab scanner. And what we'll first want to do is we're going to want to align the bite to the face or the face to the bite. Basically, we're going to be using teeth in exocad, and we're going to be using those same hard pieces of teeth to align this three-dimensional, let's say we scan the face, three-dimensional face data to the teeth and the bite that we scanned in with our intraoral scanner. We'll do the same thing with the photos. There is a feature in exocad where it gives you the ability to import photos that you could overlay onto a three-dimensional record, and it makes it a really nice way for you to capture and put your prosthesis into that photo so you could see, if you move that photo to the right plane, that you could see where the teeth are going to end up, and design it and do a good job with the design. Now, in terms of aligning the implants to the bite, now remember, the most accurate scan, right, was the implant position scan. So in this case, we happened to scan the OptiSplint with with the desktop lab scanner, and we didn't have the scan caps in that desktop lab scanner when we scanned it. It was on the model, right? And so, and you know, this doctor happened to send us another scan um, of the OptiSplint with those scan caps, with those analog scan caps in them. So what we'll do is we're going to use the desktop scan of the OptiSplint as our implant, most accurate implant record. We're going to align that to the extraoral scan of the OptiSplint with the scan caps in. And then we're going to use the scan caps to align the prosthesis to the OptiSplint jig. And then we'll use the teeth from the prosthesis that was scanned with those analog scan caps to align the prosthesis to that bite. So now you could see how we could actually align three-dimensionally the implant positions all the way back into the bite of this patient. And so now we have the implant positions and the bite in the same 3D coordinates, three-dimensional coordinates, just like we were hoping for. Now, in order to align the implants to the tissue, you could see here that the back of the OptiSplint scan body is very similar in geometry to the tissue scan caps, the multi-unit scan caps. And those multi-unit scan caps, when you scan them in the mouth, you're going to be able to capture all of the tissue around it. It's not covering like the OptiSplint jig would be in the earlier scan that we did of the OptiSplint in the mouth. It's not covering in the palate any of the tissue there, and you can capture 360 degrees all the tissue around that prosthesis. But we're using again, the most accurate implant position scan from the desktop scanner. And we're using the back of those scan bodies and we're aligning it directly to the tissue scan in that tissue scan. Now, if we didn't have the multi-unit scan caps, what we were doing in the past was we were actually using the healing caps from the patient's tissue or from the implant system that the patient used or the doctor used, and converting basically those healing caps into a similar digital geometry of the OptiSplint scan bodies, and then using that geometry to align the tissue back to the implant positions. Now, that's just an extra step, and we could show you how to do that later on in exocad when we have the exocad webinar, but it's just an extra step that you would have had to do if you only had the scan caps in there or the healing caps in there. And that typically does also still happen if you're doing a reline impression scan for an edentulous patient with a denture. So we have to apply a little bit of the transitive property here, right? So we've aligned the face to the bite, and we've aligned the bite to the implants. So therefore, by aligning the face of the bite and the bite to the implants, we're able to use the bite to align the face to the implants. So we have now the face and the implants aligned together now as well, right? We've also aligned the implants to the tissue. And so in order to align the bite to the tissue, we're using the implants as the intermediate record to align all that data together. So now we're able to get the face, the bite, the implants, and the tissue all into the same three-dimensional coordinate system so that everything is now aligned perfectly in our digital design software, exocad. And so you could see how this is happening, right? The face is being aligned to the bite, and the bite is being aligned to the implants using the analog scan caps. The implants are being aligned to the tissue using the multi-unit scan caps. Now, these scan caps are actually very unique to OptiSplint. They are not something that you can use with photogrammetry or any other technology for capturing implant positions at this time. These scan caps allow you to align with just rigid data all of these different records to each other. The face record and the bite record are aligned with rigid data because the teeth are the common points. The implant record to the bite data is using these analog scan caps. Again, they're rigid pieces of data. With photogrammetry or any other fully digital or modelless type workflow, you're kind of stuck with aligning the tissue, using the tissue as a common data between the bite scan and the tissue scan. And so that tissue, because it could move around, because it could change, that tissue is not always perfect, and aligning those can be very difficult. So having these rigid pieces of these rigid markers, basically these rigid scan caps, between all these different scans, gives you the ability to align this data a lot more accurately and a lot more easily, frankly. And ultimately, the goal here is to get all of it into the same three-dimensional position and be able to design a final prosthesis that we can manufacture. And we want to be able to, kind of design that prosthesis as ideally as possible, and make sure that we have everything in the right position, we have good occlusion, all those things, so that when we give this back to to the clinician to see back in the patient's mouth, they won't have any problems with passivity of the fit or occlusion. They won't have to adjust the bite very much. Being able to do this way just really makes it a whole lot easier and a lot faster, for the designer. And of course, we want to use that digital design file to manufacture the prosthesis. In this case, we were manufacturing a beautiful try-in. This was being done by Benjamin On at his cyber ceramics lab in Orange. He just does really, really great aesthetics, even on his temporaries and his try-ins. And you could see he printed several sets of these because we were actually using this for our JPD study. He printed several sets of these on his printer, which was, I believe, an Einstein printer, and the material was Flexera material. And he was able to characterize that material beautifully and make a really nice temporary or kind of walking try-in for that patient, so that when we actually make the final for her, it's going to be as beautiful and as ideal as possible and close to what she wants. But we do like Flexera. It's worked really well for us. You could see just how nice you can make it look in the right hands. And obviously, Ben here is absolutely the right hands. And of course, this is how we make the patients happy. I mean, you seat this back in the patient's mouth. This patient had zirconia on the upper previously done. You could see how good of a job Ben did to match the teeth color between the upper and the lower. And he did a really good job of just making it look really, really nice in that patient's mouth. The patient was super happy walking out of there. There were virtually no adjustments that needed to be done at all to make the bite fit. In this case, the patient it was a beautiful result for them. And one last time, just to go over those records, I really want to hammer these in. Just remember, for digital workflows, the thing that you always got to make sure you're understanding is you're trying to capture the face, the bite, the tissue, and the implants. And you want to capture them and bring them into the same three-dimensional coordinate system, so that your designer can actually create an ideal prosthesis for that patient. And all of those things that we were talking about, all those alignment scans, that is a digital workflow. That's what you will often learn when you go to these educational courses, is all these different ways that you could bring these four critical records together. And photogrammetry has some of their unique ways that they have to do things. Obviously, their implant records are just pop out as healing caps, and you just align those healing caps to the tissue scan. There's different ways for all of these different systems to be able to align this data together. And different clinicians do it differently as well. Like some clinicians will use some composite on the tissue to make the tissue a little bit easier to align to the bite, right? There's all these different things that you can learn to help facilitate aligning this data together. And we've done the best we can with OPTISPLINT to give you extra tools in our kits to make sure that the alignment of these different records are as easy as possible and as efficient as possible for the labs that you're working with. So this is how you think about it. There are other workflows that we could certainly go over in the future. For example, the edentulous workflow is one where you're basically doing a reline impression of healing caps, and that would give you bite and tissue at the same time, and being able to align that to the implant positions. There's other things that are similar ways of doing this, other situations, but it all comes down to these same four records and being able to align these same four records with different tools and different ways of doing it.